Hi, my friends. I would like to dedicate a few lessons to architecture and functional block of the Yokogawa system, and then we will return to our practical exercise. So, our system consists of it's a human interface station, and it provides process monitoring, alarm display, and operator control. The second one is the engineering station, and it's used for design, for configuration, and downloading our logic to controller to Yokogawa system, and it's maybe sharing also the his maybe sharing between DCS and Cs. Second, it's SENC, it's mean SIS engineering station, and also for design, configuration, and test certain system. This one. And our FCS not present. We have here cabinet type FCS, and it's a field control station for DCS controller. Performs circle process control and execute regular logic. The second station is the SCS, safety control station. It's for sys controller, and it's implement protection function and safe shutdown with independent logic. And our APCS, I think it's not here, but we used it for the process optimization models and advanced control algorithms. And next, it's our network. VNet IP, it's a control network. It's a Ethernet compatible control bus for communication between the engineering, FCS, and SCS and BSV. Then it's our layer 2 and layer 3 switches. Layer 2 switch we use for device connectivity within, in the VNet network domain, and layer 3 we use for routing between VNet network domains. Also, we have WAC router, wide area communication router for linking two VNet domains over the WAN, over the wide area network. And also we have here the generic subsystem gateway. It's a generic gateway for control and monitoring of subsystem via OPC DA. And we have the unified gateway station. It's a universal gateway station with redundancy for integrating CENTUM VP with Yokogawa Stardom controller and third-party PLC. And it support the Modbus TCP, Modbus LTU, and Ethernet communication. And last two, it's DCV. It's the bus converter for interfacing CENTUM VP with the legacy system, like the CENTUM CS 3000 or CS 1000, and also the old system like the CENTUM XL. And the last one is a VNet router. And this router for communication between VNet IP domains and the old communication name it VNet. You also print this page and write it down to remember the devices. And let's look at our controllers. We have two redundancy power supply and two redundancy CPU, and the same for Yokogawa and for the ProSafe, the same for the boss. And also I want to tell about domains. What is a domain? Domain is a group of stations connected to the control bus. It's mean domain, it's devices. You can say also domain equal to devices in one bus area. And we have 64 station maximum station per domain, and we have in one DCS up to 60 domains. And when we give the name for our station, let me write it down. We write like this. This, for example, if you use this, DCS, and for the FCS, DSS. DD mean domain number, and SS mean station number. And my friend, for the analog and digital input, we have, for example, AAER. It's 100, for example, 143. And for the digital, we have ABB 151. What I want to say about it, if you check the model and you found out that the model number starts with a 1, it's means it's belong to input. And if the model starts with a 5, for example, 5 or 3, it means the model belong to output. Any of them, analog input or analog or digital, it's belong to both. And if you model number start with 8, it means it's work like the input and output. And for communication model, we have ALR. It means that it's belonging to RS 2032, and 4085. And also for Ethernet we use ALE. And for the foundation field we use ALF. And we also have the Profibus and this module ALP. And also I wanted to explain you about the high availability of control station and our FCS availability at 99.79 is achieved by dual redundancy technology. And what it means? It means that in each of two processors of redundant control stations, there is two microprocessors, NPU1 and NPU2, that perform the same calculation. And a comparator compares the result of compares the result, and if the result is matched, the model is considered healthy, and the result is written to main memory and to the bus interface model. Memory device with error correction code correct random bit errors. If the calculation result from NPU1 and NPU2 is different, the comparator judged the result incorrect and the redundancy processor model became active, this one. And also we have the watchdog timer, which monitors the active processor model. If it's detect a fault, the redundant processor model became active. The processor model is hot standby, performs the same calculation as the active models, so it can switch to active mode instantly. And when the processor model detects an error in its calculation, it runs self-diagnostic. If no hardware faults are found in error, it's treated as a transient and the model moved to hot standby. And also each process module can connect to redundant VNet IP control bus. And my friend, a little bit about programming the control station. The control station program is developed as a graphical control drawings composed of the four elements. It's a function block. It's function block, the data link block, this one, and the wiring. Wiring, we used for the connection between blocks. And also we can add here the textual element. I mean the notes and labels about our program. And friends, that's all for now. I will try to translate the documents into English, and you will able to download them from our website, tasco.az. Let me write it down. And in the next lesson we will talk about functional blocks and then return to our practical exercise. I wish you all best. Don't forget to like the video if you enjoy it and subscribe to our channel.